Central tendency, thank you for that. Let us consider first the objectives, okay? Trey, go ahead. Let's read the 4 objectives for such.
Okay.
Thank you.
Objective 1, determine the arithmetic mean of a variable from raw data.
Continue. Yeah, all the 4.
Okay, determine the
Median.
Oh no, determine the median of a
Correct.
variable from raw data.
Correct.
Explain what it means for a statistic to be resistant,
Thank you.
and determine the mode of a variable from raw data.
Thank you. All right. So, with that being said, these are our formulas for the measures of central tendency, right? So, let's see what the different, there are only 3 measures of central tendency. The first one, called the mean, or the average, right? If you see this Greek letter, okay, that Greek letter means sigma, all right? And it only means summation, right? So it's the sum of all x values, right? Okay, so it's the sum of all x values. And then this can be written as summation xi, right? In short, sum of all x values over n. N is the what? The population size, okay? There's another Greek letter in here, just for you to be familiar with that, that is called the mu, right? That is typically the symbol for what we call population mean, okay? We differentiate mu from what we call x bar. The x bar is what we call sample mean, but as you may notice, they're basically the same formulas, okay? It's just that in a sample mean, it is divided by what we call the size of the sample. But again, the numerator is still the same, sigma xi. In short, sum of all the values altogether, okay? Later, we're going to see why did it say that this is less resistant, right? What do you mean by less resistant, okay? Next one, what we call a median. Let's read what a median is. Leah, go ahead, please.
Middle value on a range.
Yeah, so, thank you, that's correct. So you have to arrange first the data. It doesn't matter if you arrange it on with increasing order or decreasing order, as long as they're arranged. Also, it depends. If your data size is odd number, then you can pinpoint the middle data, right, or middle value. However, if your data has even numbers, then that means the middle 2, right, the middle 2, you get the average of those middle 2, you're gonna get the median, right? So again, it depends on the sample size how to get the median. If it's odd, you can pinpoint the middle. But if it's even, the middle 2, you get the average of those middle 2, right? Okay. And the last one is what we call the mode, all right? Let's read this one in here. Braden, what is a mode?
Most frequent value.
Thank you, right? So the value that has the highest frequency, the value that occurred the most, then that is the mode. And I also said in here, Avi, what did it say in here? Can be
More than one.
Thank you. It can be bimodal, trimodal, polymodal, depending on, if there are values that are equally most frequent on a data set, right? So again, it can be bimodal, there are 2 modes, trimodal, 3 modes, and so on, okay? But for the median and the mean, there's only one average, there's only one middle. But for the mode, there can be more than, one most frequent or most observed data value. Okay. Next, what do you mean by resistant, right? So when you say resistant, then that means if it's more affected, so this is less resistant. In short, what do you mean by less resistant mean? In short, this is what? More affected by extreme values. We good, guys? Right. So again, when you say less resistant, it cannot resist the variable or variability or the change in the value of the average. If, right, it turned out that one person or one observation turned out to be a higher value, then it's gonna pull that average towards that higher value, right? But the median, it's not typically affected much by extreme values, whether extremely low values or extremely big values. Get it, guys? So, let us consider now one problem in here that involves measures of central tendency and their resistance. Let's read this one, number 37. Okay? Robin, let's read this one, number 37 on linear transformations. Go ahead, please. Number 37. Thank you. Benjamin owns. Oh yeah, just in here on the border, right? Correct.
He employed none of the people. The salary earned by the employee was given to thousands of dollars. Benjamin's salary is the largest employee.
Okay, so Benjamin is the what? Is the owner, all right, of this business, right? He employed 9 people. So in short, Benjamin plus 9 people. What is the population size? 10. Very good, right? So we already know in here that the population size, big N, is equal to 10. Thank you, that is correct. Why? Benjamin is the owner and 9 more people being employed by Benjamin. So Benjamin is the employer and the owner at the same time, and there are 9 other people who are employees of that business. Okay? Now, within this data set, where do you think is Benjamin's, the owner's salary? Where do you think in there is Benjamin's salary in terms of thousands of dollars annually? Anyone? 3? Mason?
75.
Yes, very good, right? Okay. Why? But it says in here, Benjamin's salary is the largest. Obviously, right? Well, just look in there. What's the largest, right? Get it, guys? Are we good? Right? So, as simple as that one, that will be our identifying where Benjamin's salary is, right? Anyway, going back in here, let's read letter A and what we're gonna do with that letter A for such, okay? Anyone who can read that one for us? Angelina, go ahead, please.
Determine the mean, median, and mode for salary.
Thank you. All right. So there are different ways on how to get the mean, average, median, middle, and mode, most frequent salary in here. So at this point, we're gonna use Excel, right? I'm gonna explain to you as well later why we're gonna use Excel for such, okay? So what is the data set in here? Can you give us the list of the salaries that were mentioned in there? Brett, can you give us the salary, the 10 salary values? 30,000, thank you. How many 30s?
There's 2.
2 30s, thank you.
145,
45.
350s,
Ooh, 50, 50, 50,
255,
2 55s,
160,
160,
and 175.
175. Again, we said a while ago, Benjamin's is the largest salary, of course, and that is 75. Okay? Next, how to get the mean? So this is what I'm gonna do. We said our mean a while ago is what? Summation of all the x values over the sample, in this case, population size, right? Because that's the entire population. There are only 10 people working in there. 1 employer and 9 employees, right? So with that being said, what we're gonna put in here? Equal sign, put in what? Sum, right? Parenthesis, okay? And then after that, I'm gonna highlight all the salaries in here. Are we good? Okay. And then close it, divided by, here we go, population size. How many
10.
people are employed in there? 10, including the owner, right? Oops. Okay, so let's get the sum first. And then, here's what I'm gonna do. I'm gonna close this sum in parentheses. There we go. And then divide it by 10. Did I get it right? Okay. Sum A2, okay, here. Sum, and then I'm gonna change this one to what? A2, oops, to A11, right? There we go. Over 10. There we go. Get it, guys? I'm gonna change the color into red. Okay. Yeah, just to, or change the fill into yellow as well. That's just to notice that that's the mean. Are we good? Get it? Okay. So once again, what did I do? In Excel, and later I'm gonna explain to you why I'm using Excel. Okay. So what did I do? I put in there what? Sum of what? You highlight all of those numbers, right? Close it, and then divide it by the population size 10, right? So what mean did you get? You get mean of 50?
Yes, sir.
Right? Okay, good. So what does it mean by mean of 50? Anyone?
That's the average.
That's the average. Very good. Salary. Thank you. That is correct. Mean, right? What about the median? So for the median in here, this is what we're gonna do, okay? So, first, median. Arrange them in either increasing or decreasing order, right? So for the median, are they arranged in order?
Yes.
Data, right? Okay, so arrange the values or the data from 30 to 75, all right? Next, the middle. Well, first, is it odd or even, right? So step 1, arrange the data. Step 2, see the sample size or the population size. Population size, is it odd or even? Even, right? So what do we do? Here, if it's odd, so this is step number 3, pick the middle number. Right? So as easy as that. If there's odd population size like 11, 51, 71, it's easy. You can pinpoint what the middle number is. However, if it's even, what you're gonna do? Get the what? The average of the two middle numbers. By the way, if I use the hashtag, you know, in our generation, it's called numbers. We get okay. Here we go. Yeah. Well. We know it's even. So what do we do? What are the two middle numbers for such?
50 and 50.
The 5th and the 6th, right? Okay. You know what? We are actually lucky, right? Because those are just the same number. So the average of 50 and 50 is just the same 50. Get it? But again, if not, what do? You add them up, divide by 2. Get it, guys? Okay, so again in here, what's the median? 50. All right. Median 50. All right. Next, what is the mode? Again, we said the mode is the most frequent data, right? So in here, what number or what salary is mentioned the most?
50.
50, right? Again, we're just kind of fortunate because how many 50s were mentioned in here? Well, we got 1, 2, 3, right? So 50 is mentioned 3 times. That is the most mentioned salary scale or salary for this. Then that means both mean, median, and mode are all gonna be what? How much?
50.
50.
Wow.
Yeah, guys. Okay. Any questions regarding that one? Questions with what we did?
What does it say next to 53?
What does it say next to 50?
53, like your word.
This one. This is step 3. Step 1. Okay, sorry. Those are not 5. Those are S steps. Okay. So steps for median, just to give you a summary of what we did. All right. First, we arrange the data first, right? Either increasing order or decreasing order. Step 2. C. Are we talking about odd number of data set or even number of data set? And step 3, if it's odd, you can pick the middle number. If it's even, you can pick the two middle numbers, get the average of those two, right? Add them up, divided by 2. Questions? Okay, now, going back in here, talking about the shape of this data. What do you think is the shape of this distribution? Again, as you may notice in here, the skewness is where the tail is of the shape of the distribution, right? If the tail is on the right, then it's called skewed right, okay? If the tail is on the left, then it's called skewed left, right? So again, where the tail is, that's the skewness where it is, okay? However, if it is symmetric, right? There's no tail, right? It's typically symmetric, roughly symmetric sometimes as well, you know? And how do we know it's symmetric? Typically, if the mean and median are close to each other, right? Or exactly the same, then we can say that it is symmetric, right? Otherwise, here it is. If the average or the mean is less than the median, then it's skewed left, okay? The tail is on the left. However, it's skewed right, the tail is on the right if the median is less than the mean, all right? So with this being said, look at the mean and median. What can you say about the shape of the distribution for this case?
Symmetric.
Symmetric. Get it, guys? Symmetric. Any questions regarding that? Okay. So again, we can say that this is a symmetric data set. Okay. Now, let's consider now answering some more questions in here. Let's see letter B for this case. All right. Ready? All right. Letter B. Let's read it. Andrew.
Business has been good. As a result, Benjamin has a total of $25,000 in a bonus to pay distribute to his employees. One officer for distributioning bonuses give each employee, including himself, $25,000.
2,500.
$2,500.
Yeah.
Add the bonus-
25,000 is a lot, right? Okay, go ahead. Yeah.
Add the bonus under this plan to the original salaries to create a new data set. Recalculate the mean, median, and mode. How do they compare to the original?
Thank you, all right? So again, he added how much? 25, not 1,000, all right? 2,500 for each of them, right? Including himself, right? So with that being said, we're gonna go back to our Excel and add how much? On the second in here, I'm gonna put in here salary plus, what's that? 2,500. Get it? Okay. So, what will be on the second variable in here? So, I'm gonna put in here the following. Equal sign. I'm gonna make a formula out of it. Equal sign, get the previous salary, and add 2,500. So, since this is already in thousands, I'm gonna put what? Plus 2.5. Get it? Again, recall that these are already in thousands, right? So, we say 2,500, that's 2.5 of 1,000. Are we good?
A equals A2 plus
Mhm.
2.5.
So equals, click on the previous value plus 2.5, right? Get it? Okay. If I click in there, what will I get? 32.5, okay? Now here's what I'm gonna do. I'm gonna click that one, Control C for copy, all right? I'm gonna highlight the entire thing until the 10th employee, who is Benjamin, the owner, because including himself, he's gonna get the 2.5 of 1,000, which is 2,500, right? And what? Control V for, Control V for, okay, again. Copy, Control C, all right? I'm gonna highlight this whole thing, Control V for paste. Get it, guys? So as you may notice in there, every single salary was added how much? 2,500 bonus. Get it? Is it a big bonus? Well, if you talk about a year's an annual salary, a 2,500 bonus is significant, right? Okay, I mean, some people would not get a bonus over Christmas time, right? But at least they have a little bit of a year-end bonus, at the least, right? 2,500, you can do something with the 2,500, right? But obviously, you get a less tax and everything, right? Okay. Any questions, guys? All right, now let's see what's gonna happen to, what did it say in there? What we're gonna do? We're gonna compute as well the what? The mean, median, and mode, right? Let's see what's gonna happen. So, how to get the mean again? What do we do? Equal sign, okay. Parenthesis, I'm gonna put the word sum, okay. I'm gonna add all of these up first. Oops, okay. Okay, it's kind of like my thing is not working good. Okay, there we go. Close it once again, and then divide it by population size, 10. Get it? Okay. Let's see what the mean is. Oops. Okay, see that one in there? I'm gonna color it red and highlight it in green. Okay.
Yeah. Plus 2.
Since everyone, including Benjamin, was given 2,500 as a bonus on top of their usual salary, right? What happened to the average? Look at the average. Compare the average with the 2,500 and the average without the 2,500. What do you notice? You basically just added how much? 2,500 from the average. Get it, guys? All right. What do you think is the median? Look at the fifth and the sixth. Just the same, 52.5, right? What do you think is the mode?
52.5.
52.5 as well, right? So as you may notice in here, the mean is 52.5. The median is also, oops, what's that? 52.5. And the mode is the same, 52.5, right? So as you may notice, if you actually distribute equally the bonus, right? No one gets more bonus, no one gets less bonus, everyone gets across the board the same bonus, 2,500. Then the average, mode, and median is basically the same, right? You just add 2,500 to that one. Get it, guys? Right? That's what we call an across the board bonus, right? It's not an increase, but basically just a bonus. Are we good, guys? All right. Questions, guys? Questions? All right. Next one. Let's read letter C. Oops. All right. Sydney, can you see that one letter C as a second option? Anyone? Mason, go ahead, please.
As a second option, Benjamin can give his employee a bonus of 5% of his or her original salary. Add the bonuses under the second plan to the original salaries to create a new data set. Recalculate the mean, median, and mode. How do they compare to the originals?
Thank you. So instead of an across the board $2,500 each, this time it is based from their what?
Original
Salary, right? 5% of your salary, you're gonna get that as a bonus, right? So it's not an across the board 2,500, it's how much? 5%, okay? So let's go back in here and do that one, okay? Okay, so we're gonna put in here what? Plus 5%. Get it? Okay. So what we're gonna do in here? So equal sign, I'm gonna get the usual salary, right? And then times it, so this is the times, right? Asterisk, right? So equals 82, you're getting that one, times what? 5% on top of your salary. So if your salary is 100%, you add 5% to that one, so how much percentage is that? 105%, right? So in short, in here, we're gonna put what? 1.05 in terms of decimal. Get it? Okay. So once again, your salary is 30. We're gonna add 5% to your salary. Are we good? All right. As a bonus. Get it? So he got 31,500, right? So that's basically what I'm gonna do. I'm gonna copy that, Control C, highlight this whole 9 other workers in there, and then Control V, okay? Paste, right? So again, as you may notice in here, this is not across the board. This is what? Percentage of your salary, right? Definitely, the higher your salary is, 5% of that one is basically different from a 5% of a lower salary. Are we good? So again, this is what? A salary-based increase or salary-based bonus. That, guys? So let's see now. What's gonna happen to the average, all right? So put in here, what's the average once again? Equal sign, all right? Parenthesis, you sum it all up first. All of these 10 workers, including Benjamin, who is the owner, from 75,000, he is now getting what? 78,750. Ooh, it's getting good money, right? Over 10. Well, we can blame him as the owner anyways, right? And let's see what we're gonna get. We did that. Right. So what do you notice regarding the average for such? Okay, so let's color this blue. What do you notice about the average?
It's the same as the
It's
one
the
before.
same as the one before, right? So it doesn't really matter whether you get what? 2,500 or you get 5% increase on each and every one. The average is basically just the same, 52,500. But as you may notice in here, the lower salaried employees are getting lesser bonuses, but the higher salaried employees are getting much bigger bonuses, right? So that's what we call the salary-based bonus. Okay? But again, as you may notice there, the mean is basically just the same, right? Okay, let's continue in here. What do you think is the median?
52.5.
Still the same, 52.5, right? Imagine that, right? Median. 52. Oops. And for the mode, what? The same, right? 52.5. Right? Okay. Get it, guys? So as you may notice in here, in terms of measures of central tendency, you cannot notice in here that the higher salary employees getting more bonuses and the lesser salaried employees getting less bonuses. But if you look at the mean, median, and mode, it's basically just the same as saying that across the board, I'm gonna give everyone, or the employer is gonna give everyone 2,500. Get it? Okay. So, interesting, right? Interesting to see, right? And as you may notice in here, both the mean and median is not resistant to change, right? Okay. Notice that the mean and median, they don't go away from each other. They're basically the same, right? Now, let's consider the last option, right? Let's read the last option for such. Letter D, option letter D, okay? Caroline, let's read letter D as a third option.
As a third option, Benjamin decides not to give his employees a bonus at all. Instead, he keeps the 25,000 for himself. Use this plan to create a new data set, recalculate the mean, median, and mode. How do they compute to the original or compare to the original?
Okay, so he takes it to himself, right? Like, okay, I'm the owner, I'm gonna get all the bonus, right? Everyone else will not get a bonus, right? So, let's see now what will happen to the data set if that will be the case, right? So the 25,000 will be all to Benjamin by himself, right? Okay. The rest will not get anything, 0. Anyway, so only employer, right? Only the owner, right? Okay, so let's see. Oops, owner. Okay, Okay, let's see what the data set will tell us. So basically, what we got in here is basically the same for that one, right? So I'm just gonna copy that one in here. Good, Control V. You good? Got it? However, Benjamin, who got 75,000 already, will get what? $25,000 more, right? So how much will that be? $100,000, right? So he's gonna get what? $100,000. Guys, now let's see what's gonna happen to the average if that will be the case, right? So as you may notice in here, according to this data set, Benjamin is getting what? More than triple, right? More than triple the minimum salaried employees, right? Interesting, right? Now let's see what the mean will be for such. So equal sign, parenthesis. Let's get the sum first of all of these numbers, 10 numbers, and then divide it by 10. All right, let's see what we got. Still the same, 52.5. All right, but okay, so it didn't change the average. Right? It's the mean. What about the median? What do you think is the median in here?
50.
50, right? Okay, and the last one, what do you think is the mode?
50 also.
50 as well, right? So what do you think happened in here, guys?
Why is the median 50 when there's also two 30s?
Okay, question 3. Why is the median 50?
Never mind, no, I'm sorry.
Got it? Okay, got it. Okay. So, as you may notice in here, with respect to the original data set, okay, what happened? The median is still the same, 50, right? The mode is still the same, 50, right? But since owner, Benjamin, took everything of the 25,000, should have been bonus for everyone else. Well, anyway, that's his, well, he's the owner anyway, right? So it's his decision anyways, right? What does it do with the average? His big salary actually moved up, right? The average from 50, it moved up, what? 2,500 going up, right? So that's what we mean by the mean is what? Less resistant, right? Which means, what does it say here? When you say less resistant, it is usually affected by extreme values. Since Benjamin in there got all or the bulk of the money, 25,000, he pulled up the average of everyone else, right? So it seems like everyone is getting what? A good money, but actually, in reality, it's only the owner who's getting all of the money in there, right? And as you may notice, the median and the mode are basically the same. So as you may notice in there, if you are changing one number or one value and make it more extreme, meaning bigger or significantly lower, it's gonna be affecting the mean the most. Get it? Okay. But the median, it's more resistant to change. It doesn't matter if you put in a few extreme values or few lesser values, it doesn't change the middle that much, right? And similar with the mode. And why definitely not the mode? Because mode is always the most frequent value anyways, right? So the more or the least resistant is the mean. In short, it is the one that is mostly affected by extreme values, either extremely high or extremely low values, right? Are we good with what we call resistance, right? So with that being said, what happened then to the data set on the last one? When Benjamin took out all of the money by himself, what's gonna happen to this data set? Look at that. Look at this data set in here. Look at the mean and median for this fourth data set. And what can you say about this data set now, right? Because a while ago we said that this one is what? This one is symmetric, right? The same with this, the same with that, right? All in here are symmetric because the mean and the median are basically the same. But for here, look at the mean, 52.5.
Yeah.
Look at the median, 50. With that being said, what can we assume about the shape of that distribution?
Excuse me.
Right.
Skewed. Look at that one, guys. As we may notice in here, the mean, okay, the mean, which is 52.5, is what? More than, right? Okay.
Indeed.
More than the median, right? And the median is what? 50. Right? So with that being said, we can say, or we can assume that that one was skewed what? To the right. Okay, so we can assume that the distribution in here becomes skewed right simply because the owner actually pulled it right to the right. All right. Are we good, guys? Questions, guys? Questions regarding that one? All right. Thank you, Liana. So that